Okay, something that comes up quite frequently in sequences and series, which we aren't really going to get into here, the series part about it, but things that come up in sequences is a factorial notation. And it's just another operator. It's like a multiplication sign or a division sign. It's just telling you to do something. The factorial notation is really simple. It's an exclamation point. That's exactly what a factorial notation is. So if you see that within math, it's telling you to do something to your whatever they're giving you. So for example, if I was to give you n factorial, and that's exactly how it's read, n factorial. Well, what that means is a factorial notation means you're going to take the number that you're given and multiply it by every whole number all the way down to 1. So let's actually do this with a number first. Then we'll come back to the n factorial part so you can see how this works. So if I was to give you 4 factorial, well, what that's defined to be is 4 times 3 times 2 times 1. That's what a factorial notation does. And then, of course, you can simplify that, which is just going to be 4 times 3 is 12, times 2 is 24, times 1 is still 24. So 4 factorial is 24. So if I was to give it to you in terms of just this n, which is what we started with, here's a couple of things. First of all, a factorial is defined for whole numbers. Okay, you can't have 2.5 factorial. It doesn't work. But what we can do with a whole number, so we will assume that n is a whole number, is say, okay, if I start with n, I have to multiply that by every whole number all the way down to 1. Well, the number that's one number less than n, so let's just say that n was 4, well, the next number down is 3. But how do you get to 3? You subtract 1 from it. So if I start with n, the next whole number down is just n minus 1 value. Then the next whole number down from that would be that original n minus 2. Then the next number down would be that n minus 3. And that's going to carry on because we don't know what n was. That's going to carry on, so dot, 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 all the way till we get to 3 times 2 times 1. And that's how we defined n factorial. Again, make sure that you know that n must be a whole number. It does not work for negative numbers. There is one other thing that we have to talk about, and this is not something I will be proving, but 0 factorial is defined to be 1. That is something that you just need to know for purposes of doing this. There is a very interesting and long proof. It's just not something I'm going to go into right now. Okay, so let's take a quick look at what this might look like if we were given something where we had to use a factorial to find a sequence. So let's do an example where we are trying to find, again, we'll do the first 4 terms. So a sub n here is going to be defined as 2 to the n power divided by n minus 1 factorial. Okay, so let's find the first 4 terms of this sequence. So that means we need to find the first term, which is a sub 1. That is 2 to the first power over 1 minus 1 factorial. Just like anything else, you perform the inside of the grouping symbol, or the parentheses in this case, before you can do the outside, which is the factorial. So you don't distribute a factorial on the inside. So let's see what we get here. We get 2 to the first on top is just 2. 1 minus 1 on the bottom is 0, so I'm going to end up with 0 factorial, but we just talked about that is defined to be 1. So this is 2 over 1, or 2. There's a sub 1. So let's do our second term, a sub 2. Well, that'll be 2 to the second power, again plugging a 2 in for n, and then 2 minus 1 factorial. On top, 2 squared is 4. On the bottom, 2 minus 1 is 1, so I've got over 1 factorial. 1 factorial is just 1 times itself, so it's because it's no whole numbers below that to multiply it by. So it's going to be 4 over 1, which is just 4. Let's look at the third. That'll be a sub 3. That'll be 2 cubed over 3 minus 1 factorial. 2 cubed is 8. 3 minus 1 is 2 factorial. 2 factorial is defined to be just 2 times 1. 2 times every whole number down to 1 is 2 times 1. So we're going to get 8 over 2 times 1, but 2 times 1 is 2. 8 over 2 is 4. So it's kind of interesting that we get the same number twice there. Fourth, a sub 4 is going to be defined as 2 to the 4th over 4 minus 1 factorial. 2 to the 4th is 16. 4 minus 1 is 3, so we get 3 factorial. 3 factorial is defined to be 3 times 2 times 1. 3 times 2 is 6 times 1 is still 6, so we get 16 over 6. But that does reduce to 8/3 because each one can be divided by 2. So that's our fourth term. And then the general term, once again, the general term was given to us right up here. So we don't have to rewrite that. However, if you're ever asked to, then you just need to rewrite that as the general term. Okay, so we're going to actually do a couple of more examples of factorials and see how they're going to be used in simplifying, how you can simplify things without necessarily writing every single piece out. Okay, let's look at a couple of more examples of factorials and just show you how you can actually go about simplifying some of these without actually writing the entire thing out all the way down. Because the 10 factorial on the top, we know it's 10 times 9 times 8 times 7 all the way down to 1. We know that much. But that's going to get very tedious to write all that out. And then the stuff on the bottom, you've got a 2 factorial, which is 2 times 1, and then times an 8 factorial, which is 8 times 7 times 6. You don't want to have to write all of that out every time if you don't have to. But I'm going to write out at least a little bit of this to show you how this is easily simplifiable. So if I look at the top, 10 factorial. 10 factorial, like we said, is 10 times 9 times 8 times 7, all the way down to 2 times 1. On the denominator, I'm going to get a 2 factorial, which is 2 times 1, multiplied by an 8 factorial, which is 8 times 7 times 6, all the way down to 2 times 1. What you should see, this is kind of the key here, what you should see is that I've got, where I had that 8 factorial, this piece right here, that's the same as all of this. It's 8 times 7 times 6. Those two things are exactly the same. They are going to cancel out. All right, that's wonderful because now all it leaves me with is 10 times 9 over 2. And 10 times 9 is 90. Divided by 2 is 45. So that simplifies much, much easier. So we would get 45 out of that. And I didn't have to necessarily write everything out. So one thing you should be able to recognize is from this piece, since I had that 10 factorial on top and I had the 8 factorial on the bottom, we'll leave the 2 factorial there as well, I know that 10 factorial is going to be the same thing as 10 times 9 and then times 8 factorial. So I could have written it like this. And then you can clearly see that those two things would go away. And then you're just left with the 10 times 9 over 2 factorial, which again is 45. If you can't see it that way, obviously you can write it out, but this is obviously done for much larger values of factorials. And then what we're getting ready to do here in part B, where we've got things more in general. So let's say we want to simplify n plus 1 factorial divided by n factorial. Well, I know that n plus 1 factorial is defined to be n plus 1 times the next one down from that. If I subtract 1 from n plus 1, I would get n. If I subtract 1 from n, I'm going to get n minus 1. If I subtract 1 from that, I'm going to get n minus 2. Again, all the way down to 2 times 1. N factorial is defined to be, starting with n, subtract 1 from that, n minus 1, subtract 1 from that, n minus 2, all the way down to 2 times 1. What you should notice is that all of these terms right here, right here, right here, all the way down, cancel out. The only thing that's left is that n plus 1 on the top in this case. So this whole thing simplifies to n plus 1. And that's just understanding how the factorials work by subtracting 1 from each term to get to the next one. So we did a lot of really quick work there to simplify that to n plus 1.